Okay, today we're doing section 1.4, and we're going to talk about how to combine functions. And so all of these phrases are talking about the sum, the difference, the product, and the quotient. Christina. So we're going to look at two example functions, and then we're going to talk about what happens when you combine them. And then after we combine them, we're going to also talk about their domain. So the first one, this notation that you see, the notation that says f plus g and then of the x, is really only saying look at the two functions and add them up. That's it. So if I look at the functions, the first function is my f of x function, that's just x. My second function is the g of x function, that is the square root of x minus 1. And if I combine them, all I'm really doing is I'm just writing down the f function, which is x, plus the g function, which is the square root of x minus 1. Oh look, it's both the functions with a plus in between. That's what it means to add them. If we talk about domains, there are really only a couple places where domains cause issues. Or there are issues caused, I should say, maybe in the domain. One is underneath even roots, like the square root. The stuff under the square root can't be negative, otherwise you can't take the square root of that. So you know that everything underneath the square root has to be bigger than or equal to 0. Or in other words, I know that the stuff under the square root, which is x minus 1, must be bigger than or equal to 0. It would be nice if I could talk. Thank you. So then if I solve this inequality, what I see is that my domain is saying that x is greater than or equal to 1. Because the stuff under the radical has to be bigger than or equal to 0. Don't forget that if you write that in interval notation, you would be writing it this way. I'm not going to keep doing this, but 0 to infinity. Infinities are never included.
So you're saying we should stop using it should be 1? Yeah.
Okay, just see if people are paying attention. Thank you. So from 1 to infinity, not 0. In the second one, if we subtract the two functions, I would end up with x, which is my f function, minus, yep, you guessed it, radical x minus 1. Did anything change in my domain? No. Not really. There's no problems putting any numbers in for x, but still the junk under the radical has to be bigger than or equal to 0, and when I solve that, I still get x bigger than or equal to 1. Nothing has changed. If I multiply the two functions, I get x times the square root of x minus 1. And my domain is still 1 to infinity. Notice I can write it either way. They didn't tell me I had to do it in interval notation, so I can. If I want to, I don't have to. Either way is fine. Unless they specify, I don't really care. Well, look, x divided by square root of x minus 1. Put your hand up if you got that. Awesome. Put your hands down. And put your hands up if you got this. Really, with the parentheses? 1, 2, 3, 4. Why parentheses, not bracket?
Because it can't be 1. You can't have 0 on the bottom.
Can't have 0 on the bottom. If you divide by 0, that's a problem. And so we cannot include the 1. Put a star by that. Hint, hint, wink, wink, nod, nod, recorded. In this next part here, this is basically saying plug in the number. So if we remember, f was x, and g was the square root of x minus 1. And so if I'm plugging stuff in, the first part here where it says plug in a 3 when I add them together, that's basically saying 3, which is the f function, plus the square root of 3 minus 1. So the x is being plugged in into each place for the variable, and in this case, that's where they went. I should always, of course, simplify, so my final answer should be 3 plus the square root of 2. Remember to always write things in their simplified form. And the next one I'm just going to multiply. So this time, when I multiply, I'm going to have 3 times. No, sorry, my bad. 4 times the square root of 4 minus 1. Or in other words, 4 square root of 3. And the last one, it says that I am subtracting. So this one I'll have 2 minus the square root of 2 minus 1. I used that line earlier today. Don't know if you're paying attention. Okay, so if I simplify a little bit here, 2 minus 1 is 1. Take the square root of that, that's 1. 2 minus 1, 1. That was an exciting fire drill. Messed up my hair a little bit.
It hurt my head so bad, you know.
I'm sorry. That's not fun.
Wait, why is it only 1? What happens to the 2 numbers?
2 minus 1 is 1.
Yeah.
Square root of 1?
1.
2 minus 1?
Oh.
That's why.
Can we never
We are going to change something in this next part. I don't know if you've talked about this before. I don't think you have. It's called the composition of functions. So in the past, one of the things that we've talked about is plugging something in. And earlier, we talked about if you have a function like, for example, f of x equal to 3x minus 2, and I say something like find f of 7, then the 7 goes in for the x, and you would have 3 times 7 minus 2, or in other words, 19. So that's plugging something in. Composition of functions means same thing, but instead of plugging in a number, you're going to plug in a whole function. That's all it means. Shove in the function. Gannon.
Oh no, I was just playing.
For x. Shove in the function for x.
Shove in the function for x. But we're going to choose 2 different functions. I don't like the ones that they picked. So this first function down here, cross off. I don't want x cubed. I want you to write down instead x squared minus 7x plus 2. And for the second function, I don't want you to have 1 over x, so cross that out. And what I want you to put there instead is 1 over x squared minus 7. That's what I want you to do. Now there are 2 notations for composition of function. One notation looks like this, where they have f circle g and then an x. What that means is shove the g function into the x. So whichever thing comes second, that's what's getting shoved in. Whichever thing comes second. How do I know that? Well, the other notation for this f circle g of x looks like this. And you can see that the g is getting shoved inside, just like our 7 previously, for the f function. So then we'll write it both ways. You have to be comfortable with both. Some people, I don't do this, but some people teach us as fog and goth, because it looks like a fog, F-O-G, and the g is getting put into the f function. Let me show you how that works. Sorry to bore you. Here I see f circle g. This is saying to me that I want f of g of x. That's what it's saying. Or in other words, look in the f function. The f function was something squared minus 7 times something, and then add 2. This is what the f function was. What's going into the f function? The g function. So now I take the whole g function, and wherever I see those parentheses, I shove it in there. So this is going to be 1 over x squared minus 7 here, and 1 over x squared minus 7 there. In B, same thing, but it's g circle f. So this is saying to me, I want g of f of x. Or in other words, look at the g function and shove the f function into it. So the g function was 1 over something squared minus 7. What gets shoved in there? Whatever the f function was. So x squared minus 7x plus 2. And I'm not going to talk about domains in this one, so you can just, I don't want to talk about that. We've talked about domains and ranges enough. Big idea, it's just like function notation. Whatever's on the inside of the parentheses is the thing that's going into the variable. Very important concept. Probably, in my opinion, the most important thing we talk about today. Questions about this? Shove it in. Now, you, of course, you would have to simplify. You're probably not going to get anything that's ridiculous on the test because this would take way too long to simplify. But I wanted to make it very clear about what was happening, so that's why I chose these functions. Sarah? Okay, so number 3, what this is saying is they're going to give me a function, and they're saying go backwards. So we went from f and g, and we combined them to say f of g of x or g of f of x, plug one thing into the other. Now they're saying unplug them. Unplug them. So this h function in A is really two things put together. And what I notice is that there's some stuff on the inside. See the 1 minus x on the inside? You see it? Yeah. So we talked about earlier that this thing, this f circle g, is really like f of g of x. Because whatever came second on the inside. Inside, right? Whatever came seconds on the inside. So the g function is the inside.
So f would be just squared.
No, cube.
Oh, f cubed.
Yeah. So whatever's left over is what you write down for the other one, the one on the outside. So the other one was the parentheses and the cubing. And this 1 minus x is going to get shoved into that parentheses. But I need to write something down there for right now. So I'm just going to put down x. Because that 1 minus x is going to get shoved in there later on. So the thing that comes second is the inside stuff. Let's try that again. Part B. The inside stuff is 9 minus x. So that means that my g is 9 minus x. What's left over? A square root. So I write down the square root for the f. Well, there's nothing in there. I want to shove that in later, so I just write down x. That's it. In number 4, we're going to use some graphs, and we're going to evaluate, which means find the numerical answer. Bless you. So I'm going to do one example, and then I want you to try the other 3, and we'll come back and talk about them. First of all, remembering that f plus g